Hey guys. Like I kind of listened to Jane's speech and I was kind of like a little bit bedazzled because like I'm pretty much the opposite of the scenario he posed. Like I'm like the opposite of a genius. So I didn't memorize any of this speech. So I'll literally just be like reading off here. So if I'm just like this the whole time, just don't take it personally. So my name's Lucas. A bit of background on me. I worked as a front-end web developer for a top-notch medical startup called Next Practice, based in Surrey Hills. Woo! And they are hiring, so go talk to them if you want a job at an awesome place. So I've recently had to relocate to Queensland, but I happen to be in Sydney this week, so here I am. It's also my first time speaking here. Really glad to be here and have you guys as my audience. And I hope to be able to give more talks in the future, if my intellect permits. So today's talk will be about what's new in React 16. Not sure if you know, but React 16 has been out for more than 4 months now, which in JavaScript time is like 2 decades. So I expect that basically all of the React devs in this room probably have some sort of idea of like what exactly is in there. But if not, I'll be here to kind of fill the gaps, and I'll try to keep the talk a little bit simpler. So like if you've never worked with React before, or if you're just getting started, it's hopefully a great time for you to hear some of my possibly valuable insights, and perhaps a recommendation or two about what to do to best prep for the possible future of React. So what exactly is React 16? It's also known as React Fiber, and it features a full API-compatible internal rewrite, a few new features, and a shiny MIT license. Fought for that one for a while. So the internal React Fiber rewrite has made rendering much faster and a lot more fluid. So what it does is now basically it prioritizes certain things to render over others. So it figures out what needs to render before something else. So for example, when you're typing on a keyboard, you'd expect instant feedback. You press the Q key, you get the letter Q. But when you're updating a list of items, it's probably okay to have a 350 millisecond delay, something like that. Yeah, so anyway, so this is a visual representation of React 15's render cycle. As you can see, the single render thread, so the web is single threaded, goes down the nest of components and kind of stays down there, hiccups a bit, jumps around a bit, but it never really quite gets back to the top. So what that really meant for React 15 is it basically limited the amount of optimization that they could do. So then what they did is, as Facebook does, it updated the whole library, rewrote it, and now uses what they call a fiber data structure. So it lets you go up and down the component tree, figure out exactly what you need to update, and check if anything else is more pending, more urgent to update. So what does this mean for us as React developers? Nothing much, because these changes, I'm just being honest, I mean, come on. So these changes are almost entirely internal, meaning that the way you write code really won't be impacted. It's just nice to know that React is being actively and ferociously maintained and improved, and that just means that it's a great time to start using React if you haven't done so already. React 16 also introduced a couple of new features, and you can find a full list of the changes on React's GitHub releases page. The main 4 I'm going to be talking about are portals, error boundaries, improved server-side rendering, and returning additional data types from the render method. So a portal is essentially a section of content rendered by React outside of your root DOM node. So let's assume that you made this wonderful web page over here, and that this is your React app. But what if you wanted your React app to render and control something in the sidebar? Well, you can do exactly that with a portal. The content of the sidebar, although now sitting outside of your React app, is still controlled by the components inside your app. This makes portals a really good candidate for stuff like modals or any other sort of like pop-up content that would normally be displayed in a separate section of your page. Writing up a portal is really easy as well. This is how you'd normally render content within React. However, if you want to use a portal, simply use React DOM.createPortal on your content and provide it with an HTML DOM node to render into. So DOM node probably being something like document.getElementById sidebar, right, or something like that. So that's all you would have to do. And now any updates on your parent component will trigger updates on your portalized child component as if it were a child of the actual parent. So another great feature of React 16 is the error boundary. So let's just say that this somewhat dodgy ice cream truck is an error thrown by one of your components during its render cycle, and it's traveling up your component tree, and it's about to be emitted out of your app and into uncharted territory. How would you stop this? With an error boundary. And that's exactly what it does. So as an error boundary would do, it would stop it and make React great again. So this is the code that you would use for such an error boundary. So if you can't see that up the back, I apologize. Basically, React 16 introduced a component did catch method. And we simply use that to catch any errors that occurred in the render methods of any of its children. Not in the component itself, so not in any code here, but in its children. So if you were to use this component, you'd simply use it like so. You have it around your widget or around your code. And then if any errors were thrown in the wrap component or any of its children, these errors would be caught by the component did catch method of your error boundary. So what does this mean? It means you should have at least one error boundary within your React app, preferably more. When an error is thrown, you should look to use component did catch in your error boundary, and as per UX design guidelines, provide the user with as user-friendly an error message as possible. This is where it helps to use multiple error boundaries, because then you can kind of like say, well, something happened in this part of the app. You can make the error message more relevant and make it more friendly for the user. It's then also a good idea to send these errors via error logging software to your dev team. So a couple examples include Sentry, Rollbar, Bugsnag, New Relic, Jira. I don't know. Yeah, maybe. I don't know. Or you can just do that. I mean, like, good old. See, now people are starting to get it. So yeah, but React 16 also has an improved server-side rendering engine. As a result of the internal rewrite, its own rendering speeds have substantially improved. React 16 also introduces streaming, meaning that the browser can preemptively start to load your web page without having to wait for the whole page to load. It does this through the use of two React DOM methods, render to node stream and render to static node stream. One of them is static. So the first one renders a node stream, which means that it can be picked up by your client-side React code. So if you've got a web app that you want to render on the server so it's a bit faster or improves your SEO, it would be a good idea to use the first one. If you're using React simply just to render a static website, the second one would be more in your favor. So these kinds of things, in addition to the React DOM hydrate method, which makes it a lot faster, it basically performs some internal magic, connects to your code a lot more quickly. It makes it a very interesting time to consider the server-side rendering potential of React. So what does this mean? I guess it makes it a really great time to go hard on server-side rendering. So around the start of November last year, Netflix announced that they've completely abandoned client-side React for their homepage, preferring a server-side React render. Another potential idea worth investing in is the use of React solely as a server-side templating language, perhaps replacing your typical Mustache, Pug, and Twig. Many front-end libraries are now being released on the pretext. There was one by Alibaba recently called Rax, maybe not recently, but its pretext is basically it's 5 times faster than React on development mode. But then on production mode, it's probably like half the speed, half the time taken to render a web page, which is pretty much the same as Vue, but it's Alibaba, so it's Chinese. Docs make no sense. But yeah, what I think that is going to cause is that's going to cause rendering speeds to just improve overall, because everything's open source. Obviously, people share ideas, share knowledge, and all the best stuff then gets incorporated back into the main project. So I think we're just really going to see that React just gets faster and faster on both the client and the server. So I think it's definitely a good time to start building, your universal server-side React apps using React and Node.js. React 16 also allows strings and arrays of elements to both be rendered as well. The only thing is that if you're rendering an array of elements, you have to provide each one with a unique key. You can see the keys over there, first and second. So what do you do about this? How do you get around this? A good way to do this is to use an auxiliary React component, like so. So you have a component like aux, and it just takes in the props, and it takes the children prop, and then just spits it back out. So then you can just have an H1 and an H2, but then you would render them without needing to have a key on them. And another way to do it is to use the following syntax in React 16.2 and above. So React.fragment is basically the same thing, but now written into React. And if you're running Babel 7, you can also do the following syntax. But Babel 7 is currently experimental, so probably stay away from this for a little while. So that's just a quick run through of the major changes in React 16. But what about the future? So the JavaScript environment just seems to keep getting better. So Chrome's V8 engine, on which Node.js is developed, is continuously improving, making it faster and faster to parse and execute JavaScript. And that just brings React server-side performance along with it. Just gets better. Other browsers are improving their runtime environments as well, meaning client-side performance will only get better and better as well. We're probably going to see long-term support for experimental features such as context get consolidated, and both server and client-side rendering speeds will improve as a direct result of upgrades to React's algorithm and the environment in which it runs. So how do we prepare for this? To be honest, no idea. I wish I knew, but 2 years ago, my projects were still getting built by a bird and a pig. And now it's some weird 4-dimensional hypercube that demands I write a 50-line configuration object every time I want to create a basic Hello World app. You all know it's true. However, the things that I've seen consistent over all this time are best practices in coding. So what I think will stay consistent is that not a library or a framework, which will say best practice forever, but an idea, a concept, something outside of the immediate scope of the language and its immediate features in which you are developing. For example, the async and await keywords that are now so dearly loved by JavaScript devs, and you'll know what I mean, was taken from C#. So it goes to show that when there is a good idea, or there is a best practice, it's very hard for that to go out of date. So let's just assume that React steadily gains a greater and greater following. React Sydney expands to take up this whole floor, maybe, hopefully. So then what should we do to welcome future versions of React? One example of a React best practice to follow is the use of functional components, basically components that consist of only a render method. So what this means is that it makes them a lot lighter, and it automatically makes them a pure component. No? No? Okay. Well, I'll go on, and you can correct me. They should always render the same result when given a specific set of props, making their behavior very predictable, and making it very easy for React to optimize their rendering. Although render times for functional components and their class-based counterparts are currently the same in version 16 of React, expect future updates to decrease the render time for functional components for sure. Another good example is the currently experimental context API, allowing you to provide data to components nested far down in a React hierarchy without having to pass the data down as props through every single intermediate layer. React says very clearly on its website that context is likely to break in future releases of React. However, it's nonetheless used by many libraries to manage data flow, the most famous of which are probably Redux and React Router, and the React Memory Library you just heard of. Well then, what do we do about this? How do we use the context API whilst being as flexible to future change as possible? How do we be flexible to future change as flexible to future change as possible, full stop? I believe that the answer lies in componentization. So just keep React components as simple as possible and for one single purpose. Make more components. So when Facebook released React 16 last year, they stated on their website that they have currently more than 30,000 components just on their main repository. So when you're componentizing, also try to keep any volatile code, anything that's likely to change and of a similar nature, in a single place. A higher order component would be perfect for something like this, and it's exactly what Redux uses to keep its context usage in one single place, waiting for possible API changes in the future, patiently yet expectantly. And I think it's with that attitude that we should patiently yet expectantly wait for future changes of React as well. Thank you for listening.